Good evening and welcome guys. Today this is Chahel here and I will walk you through the solutions of Codeforces Round 808 Division 2 as you can see. Now I was able to solve problems A, B and C during the contest and I upsolved the a little while after the contest. So now let's move on. So first we'll discuss problem A. So in problem A, we are given an array of positive integers and we are allowed to make this particular type of operation, and we have been asked whether we can make all AI 0 except for the first element. Basically, we can take an element and subtract it from the next element, and we can do this any number of times that we want, possibly 0. So we just need to tell whether we can achieve this or not. So as you can see, first we have 4 test cases samples, and in the first test case, like they have given us the R as 5 and 10, so obviously you can subtract 5 twice from 10 to get 0. Then in the next case, they have given us 1, 2, 3. So now if we subtract 1 from 2, we get 1. And now we can subtract 1 3 times from the last element, and that will lead the last element to be 0. And then we'll make this element 0 by subtracting 1 again. So it's possible for the second test case as well. Now in the third test case, we can just take the second last element and subtract it with the last element, and then we can do the same with the third last and second last element, and then with the first and second element to eventually get 1 0 0 0. However, now on moving on to this test case, the test case 9, we can see that on subtracting the like we can probably make this 0, but 9 we can make the second element as 0 if we want from 9, but we can't use it to make the third element 0. If you can see, like subtracting either this value can be 9 or 0, and subtracting that from 8 won't lead us to the solution to make it 9 0 0 0. So what we have noticed is basically that we are given this array a1 a2 a3 and so on up to n. Now in each operation what we can do is we can subtract the preceding element from the next element. Now cast notices say that it is possible that we can achieve after a few operations that the first element remains AI and all others become 0. So the interesting thing to note in this case will be that from A2 we can subtract only AI because AI cannot be changed. So AI will divide A2, and at any instant, say A2, we have subtracted AI k times from A2, so A2 is something like A2 minus k times A1. So even this number A2 minus k times A1 shall be divided by A1. And this tells us that we'll be subtracting this number or numbers of this form from A3. So that, and A3 has to be 0 after all the subtractions. So that tells us that A1 also divides A3, and so on by induction. We can generalize that AI A1 divides AI for all I, if it is possible to reach the final state of A100. So this is the condition that we need, and then we just implement it via the code. So now, so this is how I've implemented it in the code, as you can see. So first here we have taken the test cases on fast input output, and then we just take n as input, we make an array of AIs, and we just keep checking if AI is divisible by A0. If it isn't, then E will become 1, and that will indicate us after the loop that like if E is 0, then we are outputting yes. If not, then we are outputting no. So that's pretty much it for the first question. Now, moving on, we go to the next question, differences of GCDs. So we can see that in this question, we are given some 3 integers and then a full array of length n, and we wish to construct this array actually. So it's a question of constructive algorithms. So usually what happens with such questions is that uh, it becomes tough at times and at times it's easy. Like there's no middle ground in constructive algorithm questions. It sort of depends. Like at times you might find them very tough and you won't get the idea, but suddenly if someone tells you, be able to appreciate the answer. So usually these questions take time. And what they've told us is that GCD of I comma AI is distinct. So we need to, and all AI should be between L and R, and we need to tell if this is possible or there's no solution. And here GCD is the greatest common divisor, and they have given the input format and the output format, and these are the test cases. So I guess so if you weren't able to solve this, I guess I'll walk you through the test cases and then you can try it again once by pausing the video. So we can go to the test cases now. I'll just write them down for a second. So it's 515, 9000 and 2000, 10, 30, 35, 1, I think that's 10 power 9, yeah, 10 power 9 and 10 power 9. So alright, first test case we have 5, 1 and 5. This is L, this is R, this is N. So we want an array of size 5 which will have distinct GCDs. So in this we have a very trivial solution that we can just take the arrays 1, 2, 3, 4 and 5, because like this will give GCD 1 with 1, this will give GCD 2 with 2, this will give 3, then 4 and then 5. And so we easily, and those are within bounds. So that's a trivial solution for the first test case. Now, second test case, we need 9 numbers from 10 power 3 to 2 into 10 power 3. Now, we can see that they have solved this by taking these numbers. I guess, okay, multiple solutions exist for this one. However, we can see that the GCD of, basically if you check this answer they have given, that's correct. Uh, and then we can move to the next test case, that is 10, 30, 35. So here they have said that it's not possible. Okay, that's also cool. And then 1 10,000, 1 10 power 9 and 10 power 9. So they have said that here also it's possible and it's just 10 power 9 because they have only one number, so it's distinct. Now we can sort of, as it is constructive, instead of solving the test cases, we can try to solve this question in general. Like you are given some n, l, and r, and you need to construct such an array. So firstly, we'll see that the first index is I equal to 1. Now a trivial note is that GCD of any number and 1 is 1. So if we create such an array, something like A1, A2, and so on up to AN, and then we do a GCD of it, so the first round will correspond to 1 only. Now a thing to notice is that all elements should be distinct. So now we can try to find what will be the GCD of A2 and 2, and we'll have to make it distinct from 1. So I feel that this is a decent amount of hint, and you can pause the video here and try to do that for A2 and then see what happens next, so on by induction. So you can pause the video if you want to try it, else we'll continue. So now if we take A2, so A2 will have its GCD taken with 2. And there's a very interesting thing to note that GCD of A2 and 2 is less than min is less than 2. Basically, yeah, is less than equal to 2. However, the GCD is always positive. So the only possible values for GCD are 1 or 2. But as we can see that the first element is already 1. So this will have to have GCD2. And so we have found out the GCD for the second element. And so on for, like, if we go on A3 also, its GCD will be taken with 3. And so the only possible values are 1, 2, 3. And 1 and 2 have been taken, so its GCD will be 3. And so on. What we'll get is that AI, comma I, GCD of AI, comma I equal to I. Now, this is a very interesting observation, and this basically implies that I divides AI for all I. So what we need to do is we just need to find an AI between L and R such that it is divisible by I. So for this what we do is we check that we compute L by I and R by I. Now if L by I and R by I are different, like this is the integer division, not the normal division that we do, but integer division, we just take the quotient. So if the quotients are different, then obviously we'll have an answer, and we can just directly report it as R by I into I, because this number will be between L and R inclusive, and it will be divisible by I. So it will work out as AI. Now say these both are equal, Li is equal to Ri, L by I is equal to R by I. So now two cases arise in this case, that I divides L or I doesn't divide L. So say I divides L, then we can directly take AI as L. If I doesn't divide L, that implies that L and R both are in between two multiples of I, ki and k plus 1I, and so any number between them won't be divisible by I, and so in this case we'll output -1 or no, however they want it. So yeah, no, we have to output. So here we can see, and that's how it will happen. And so now I have implemented this in this way. So first we have taken the test cases, then we are taking an R as input and creating that array of A where this we have created a vector of A. This vector will be our answer basically. So now what we are doing is we are iterating from 1 to n. We are calculating x and y, which is basically our L by I and R by I here, and then we are checking the three cases that we mentioned, and we are keeping a token or a value e, which becomes 1 if at any time we make the can't find an AI, and it will become 1 on break. And if it's 1, we'll see out no. If it's not 1, that is it's 0, then we'll see out yes and the whole array. So that was the problem. Now moving on to the next problem, which is problem C. So this I felt was a rather tough question, and I had a kind of bad time in it because my first submission had a runtime error, and that was just because I was accessing a element outside the what I had defined, and that was kind of harsh. But yeah, overall this was a hard problem I felt. Now, so and I think that's deserving for a C problem. So in this problem, there's a girl named Doremy, and she has to test n contests, and she can test contest I only on day I, and difficulty is AI, and her IQ is Q. So she'll decide whether she wants to test her contest or not. If the difficulty of contest is higher than her IQ, then she feels that she isn't wise enough and her IQ decreases. Otherwise, nothing happens. Like basically, she can attempt a contest of having difficulty equal to her IQ, and her IQ will remain constant or even lesser than her IQ, and it will remain constant. Constant. So she chooses. Uh, so now we want to make her give as many contests as possible. So we need to give her a solution. Basically, we need to output a string of length n of ones and zeros, where 0 denotes that she didn't give that contest, and 1 denotes that she gave that contest, and we need to maximize the number of ones in that string. So for this, we can try to go through the test cases first and see if we can find some pattern. Again, this is a rather tough question, and it's fine if you didn't get it in the contest. Uh, so yeah. So the first test case is 1 comma 1. Basically, okay, wait, in the first question, there's one contest and her IQ is Q, that is 1. And the difficulty of that contest is 1. So obviously, as the difficulty is same as her IQ, she can give that contest easily, and she won't even suffer an IQ loss. So for this test case, the output will obviously be 1, which is the output. Now, if we move on to the next test case, it's something like, yeah. So there are two numbers, and her IQ is 1 initially, and the two numbers are 1 and 2. These are the contest difficulties, 1 and 2. So if she gives the first contest, we can see that it has the same difficulty as her IQ, so her IQ won't change. And now if she gives the second contest, then it has more difficulty than her IQ, so her IQ will decrease and become 0. So even though it becomes 0, in this case she can give both the contests. So we'll output 1 1 in this test case. Now the next test case is her IQ is 1 and the contest difficulties are 1 2 and 1. Right. So now she can obviously give the first contest because it has the same difficulty as her IQ, so even her IQ won't change. So it doesn't affect the later ones. And now say she gives the second contest. So her IQ will decrease and it will become 0 and she won't be able to give the last contest. So she'll be able to give two contests in this case. Like other than this, she could have decided that she'll give the first contest, not give the second contest, and then give the third contest. But in either case, she'll be able to give only two contests. And the possible outputs for this one will be 101 or 110. Both of these will be acceptable, I think, and should work out. Now, moving on, we go to the last test case, which is her IQ is 2 and the contests have difficulty 51243. So in this, let's say we give the first contest. Okay, she gives the first contest, then her IQ decreases to 1, and then in all of the contests she can give only one, only two contests more. Like if she gives one contest, her IQ will remain 1, and then she can give one more contest, and her IQ will become 0. So in this case, she can give three contests. However, say she doesn't give the first contest, her IQ is still 2 now. Now she gives the second contest. Okay, it has difficulty 1. Her IQ doesn't change. Same with contest 3. Her IQ won't change. And then there are two contests. She can give both of them and suffer a IQ loss, but she'll end up at 0, and she'll be able to give four contests this way. And this is the maximum possible that she can give. And in this case, the output will be 10011. So one thing that we can realize is that we need to maximize the number of contests she gives. So at any time, we like that her IQ is as high as possible. Like we like to decrease her IQ as late as possible in the series of AIs, so that basically, suppose we do a decrease earlier, and there's some AI which is equal to her IQ at this point, but we won't be able to get that contest because now we have reduced her IQ. So what we'll aim is that we'll want to give all the tougher contests as late as possible so that we can maximize the number of contests given. Now, I think this is a fair point to pause the video and work on it yourself if you couldn't solve it in the contest, because it's a decent amount of hint and you can try it out. Now, say we move on, and now what we want is that all the decreases should be in the last. And to be most optimal, we'll want that her IQ reduces to 0 at last, because if her IQ isn't 0 at last, we might be able to give one more contest extra and then reduce it to 0. So now there are two cases in this. So basically, one is that even after giving all the contests, like she decides to give all the contests, her IQ is still 0 or greater. So in this case, she can trivially give all contests and we can just output 1 for every contest. But suppose this is not possible, which is what will mostly happen in the input cases that they have given. So in that case, what we'll do is uh, we'll sort of start to traverse the array without reducing her IQ, and we'll find out all the contests that she can give without reducing her IQ, and she'll leave the other contests in the meanwhile. Alright, and then after a point, we'll to find this point. So after this point, we'll start to give all the contests that we can give, and her IQ will decrease and and should decrease to 0, or maybe not 0, but either ways it will decrease, and till the end of the array, and we'll be able to give the last contest as well. So now it's challenge to find from where do we start giving all the contests. Now you can pause the video and ponder upon this, or we can just continue. And so what we'll basically do to find this I is that we'll start from the end of uh, the array, and we'll go backwards while increasing her IQ, and we'll see that when her IQ, like at what instant her IQ reaches the IQ that was originally given in the question, and then we'll store this I, and we'll find out all the values at which giving a context doesn't change her IQ, and we'll traverse the array from left while outputting 0 and 1 correspondingly for these values, and 1 for all values here. And this is basically the constructive algorithm that will satisfy this question and also maximize the number of contests given. So you can see my implementation for the same here. Uh, so yeah, first I've taken the test cases here, and here's my solve function. So I've taken the input n and q, and I've just made one more value L as equal to q. I'll use this L to basically compute what her IQ would be if she gave all the contests. So, and I have made two vectors. One vector is to take the input A, and another vector is which will store the contest that she can give without an IQ loss. So now we are taking the input AI, and then we are, if it is less than or equal to Q, that is it doesn't affect her IQ, so we are pushing it into the vector, and at the same time we are updating L as we go. So now once we have done this, so we check if L is greater than equal to 0. If it's greater than equal to 0, that's perfect for us. We can just output 1 and we'll be done with it. If not, we'll move on. So now we define three variables, a counter, P and I. So this I will help us find out where we have to give only the easy contests. So yeah, so we traverse the array backwards. As you can see, we have set I as n minus 1, and we are traversing it backwards. And p is our auxiliary variable, which is our IQ that goes from 0, and it will increase backwards till it reaches q, as you can see. And as soon as it will reach q, we'll break through the loop, and we'll get the corresponding value of I. We are just increasing our IQ backwards. And then once we have got this I, so we'll start from the left side, and we'll start outputting 0 or 1 corresponding to whether it's a easy contest or not. And then we'll output 1 for all the I from I to n. And that's it. And I had got a runtime error in this line basically. So first in this if clause, basically I had merged these two, and count was going greater than the size of ease, and that was causing me a problem and giving me a runtime error. Now moving on to the last question that I've solved, that is problem B. So this was a very interesting question. You are given an array A which is of non-negative integers only, and A is already sorted. And for every operation, what we need to do is we need to construct an array B that will be a difference array. Basically, we are subtracting the consecutive elements, and then we sort B also and decrease n by 1, and we keep performing this operation, and we do it till the time the size of our array becomes 1, and then we just need to output whatever we get the final answer in the array. So now let's do the test cases for these questions. So the first test case gives us three integers, which is 1, 10, and 100. So in this, we can first take the differences. That gives us 9 and 90. And this is already sorted, so we don't need to sort it. And we can directly take its difference as 81. Now in the next test case, we have four numbers: 4, 8, 9, and 13. So here we subtract the consecutive elements, and we get 4, 1, and 4. We sort this to get 1, 4, 4, and then we take its difference to get 3 and 0, sort it to get 0 and 3, and the difference is 3. So we'll output 3 in this case. Now we can skip the next test case and the last one because they are rather trivial, and we just cover this test case: 2, 4, 8, 16, 32, and 64. Now here we'll take the differences, and we get 2, 4, 8, 16, 32. Again we take the differences, we get 2, 4, and 8, and 16. Again we'll get 2, 4, and 8, and then 2, 4, and then 2. So our answer in this case is 2. Now we'll just cover the last test case, that is all zeros. So they have given us like 6 zeros or 5 zeros. So one thing to realize is in this is that we can just, the differences that we'll get is 0, 0, 0, 0, 0, 0. And as you can see, we could have set this directly as it's all 0. Now we have one test case that is very interesting in the sample test cases, that is 3 zeros and then 8 and 13. So we take the difference array, we get 0, 0, 8, and 5 sorted to get, and we can just drop these 0 elements because they don't affect the final answer. So if we do that and sort it, we get 5 and 8, and then we take the difference, it's 3, and that's our answer pretty much, because we'll have all the zeros here that will eventually get 3 only. So that was that test case. Now as we can see the bounds on this question, like if you check out the bounds, if n is given till 10 power 5 and ai's are given till 5 into 10 power 5. So a very interesting thing to note in this question is that ai's are not random and they are bound above by 5 into 10 power 5. So what that implies is that we have to find an algorithm that is either O of n log n, or O of an, or an log n, something like that. So that is a very big hint because AIs are bounded above. So a trivial approach to this question would be that we'll take the first array A, and then we'll calculate its differences, sort it, then calculate its difference, and so on till we reach it to an element. And this is a good approach, but the problem with this approach is that each step in this approach will roughly have a time complexity of n log n, and so the whole approach will have a time complexity of O of n square log n because we need to do it n minus 1 times, and this will give you a time limit exceeded error, TLE. Basically, this is what I had done on my first try, and I had got time limit exceeded on this in test case 3. Like, yeah, here you can see, so they gave a very big input and I got time limit exceeded on that. However, we have made a very interesting observation in this test case. That is, the zeros don't matter. And as the AIs are bounded above from 5 into 10 power 5, eventually after a few observations we'll get that many elements of the array are 0, and we can just drop them off, and that will significantly reduce the number of elements and will help us solve the question faster. So what we basically need to do is that calculate difference array and drop all zeros, then sort it, and apply this procedure recursively till we get only one element. And this is a brute force approach and not exactly appreciable, you can say, but it was a brute force question, and it is a very hard solution to come up with in the exam unless you think about it a lot. But the hint here is the test cases, which is what we have to uh, realize. And so we'll go through how I solved this question by my submissions, basically. Wait, just a second. I'm having a bit of a trouble finding my submission, but so if I go in my profile and check my submissions, it isn't showing my submission for the question. Wait. Yeah, that's my solution. So basically, what I've done is I've taken the input as n, and then I've created a vector of size n, vector a, an array of vectors of n. So basically, this array of vectors, it will store the various difference array that I'll get. Like the first one will be the original array, and then so on. And it's a vector, so the size is dynamic, so it won't be an issue. So first, we take the input in a of 0 vector. Then what we do is we sort the vector to get it in increasing order, and then we just see that as long as we don't then this is just the corner case, that first we have taken this difference, we are checking if the difference is greater than 0. If it's greater than 0, then we are pushing it back, and we are doing one more check that size of AI is not less than n. If it is, then we are just pushing back the first element. We are doing this because if say you see this solution of 5 and 8, if you take the difference in it, you'll get 5 and 8, but after that you'll get 3. But you need to notice that 3 is not the answer, and rather 2 is the answer for this question. And it is very interesting how that comes, because 1 0 matters actually. So we need to have 1 0 before it, and we'll take the zero difference of 0 and 5, and that will give us 5 and 3, and their difference will be 2. So this is an observation that we have to make, and this is a corner case that people might miss. So this is that corner case that if the size is less, then we have to just push back the first element, because it implies that if the size is less, we have dropped off the zeros, and 0 minus first element won't be there. So that's why we are pushing it back. And then we have just made a check that if the size is 1 or less, then we just break the whole loop and we output the size. If the size is 0, that means that basically there are no differences, so we are reaching 0 in the end. And so we are directly outputting 0 in that case. And this is basically the solution for the problem D. I hope you enjoyed the editorial, and if you have any doubts or any suggestions, feel free to put in the comment box. Thank you.